Retro.
Yeah.
Electro. Tech.
Oh yeah.
Hey, turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Well, hello there once again, ladies and gentlemen. This is Retro Ernest of Retro Electro Tech. And this time around on the bench is a Sansui 6 stereo receiver from right around 1972. I believe it may have had a production run of about a year, so 72 to 73, something like that. And this comes stepping into the ring at 28 watts per channel into 8 ohms to tickle your bones. And this particular unit came to me with a customer complaint that we have a dead channel. I don't know anything beyond that. So I'm going to go through the usual obligatory inspection. Pop the hood, take a look inside, look around back, check fuses, things like that. Just do a kind of an exterior inspection, I guess. Look over. So let me just go ahead and get to it and get the cover off this thing. Okay, so here we are. And I'm going to keep this section really brief because I want to get to powering up this unit safely, of course, getting a signal into it and see what's going on with that channel, whichever one it is. Yeah, we have our power supply, main power supply area here. We have our amplifier section, heat sink and all that, tuner, and we have a nice chunk of transformer. A lot of dirt in here as expected. I mean, this is an old unit, over 50 years old, thereabouts. So actually what I'm going to do before I get this thing flipped over is look around back. Okay, so here we are at the rear, of course, and I have her booty propped up because, well, that's a gentleman thing to do. So let me go ahead and check our line fuse for starters, and we should have a 5 amp fuse. And let me bring my light into the equation because my eyes are not so great. Yeah, 5 amp fuse, yep. And it looks like it's intact. Sometimes when the element looks like it's intact, it may not be, but I'm pretty sure it is. But just for the sake of thoroughness, yep. So let's pop that back in there. And we have some other fuses here. That's for our amp channels. Yeah, it looks like there's a couple that are open right off the bat, so these over here. Yeah, those are open. Probably can't see them. I doubt it. Gets blurry if I hold them up too close. Let me see what they are. I think they make sure they're properly rated. 4 amps. 4 amps. That's what they're supposed to be. So I'm just going to set these open fuses off to the side here, and let me just check these other ones. So I'm sure that's why we have a dead channel. And yeah, these look like they're intact, and they're both also, let me make sure that these are also 4 amp fuses. Yep. Okay. Let me just test them real quick. Again, the elements look like they're intact on these. Yep. Okay, good. All right. So obviously I'm still going to perform a safe power up. I want to see what the other channel's doing. and just take a look at the waveform. Make sure the waveform on the working channel is looking okay. In addition to that, I'm going to go through and manipulate the controls and see how bad those are or how good they are. And of course, I'm going to end up doing a deeper dive if the customer wants me to move forward, which I assume he's going to want me to do that. I'm sure we have something going on, probably, some shorted outputs maybe, or some other transistors, or maybe even some caps that, poop the bed. So there's obviously a reason why that, why we have those open fuses and why that channel went kaput. So let me go ahead and get to it and start with a safe power up and see what we have going on there. Obviously, through the process of piping in a signal, looking at the waveform on the working channel, I'm not going to let it off the current limiter. It's going to be heavily current limited. And yeah, there you go. So let's just go ahead and get to it. Oh, you know what? I forgot. I am going to look at the bottom side real quick. And of course, here we are on the bottom side. Everything actually looks really, really clean under here. Doesn't appear to be molested. It looks all original, all the components. And yeah, from what I can see, of course, I'm going to need to spend some time and get my magnifier under here when I start getting into servicing this unit, if the customer wants me to go forward, of course, depending on what I find and all that. But yeah, once I start getting in here, I'll start looking things over in more detail, obviously, as I always do. But from what I can see just off the bat, I don't see anything that's charred or discolored, just glancing at the different resistors and various components and all these caps. I don't see anything bulging. I don't see anything leaking, physically leaking. And what you're looking at here, this board, this is our tone board. You can see all of our controls here. It's a real spaghetti factory, as you can see. But oh yeah, all the wiring looks super clean. Everything looks good. And here's our protection board down here. Let me pan down just a little bit. Yeah, we have our protection board here. I don't know. Yeah, you could probably see these the bottom of these blue sockets here on the top side. These are where our driver boards plug in, our amp boards, driver boards. And yeah, and then we have over here, we have the bottom of another board, real spaghetti factory, but this is a power supply board. Here's our main filters, and yeah. So anyways, yeah, everything looks really nice under here. I'll be honest, it's built really, really well. Accessibility isn't bad. It's just that there's so much wiring that's the only thing. If you really start having to, pull out some, controls especially, that's, yeah, a lot of wires. A lot of wires to contend with. But the pots themselves look pretty accessible overall, but to do a really good thorough job in cleaning the contacts, especially these wafer switches and all that, you really do need to gain access, and that's going to be well, it is what it is. But when you have all those wires and you're pulling controls out, yeah, sometimes that can be kind of a pain. And I don't know yet what it's going to be like gaining access to the switches, how accessible from the top. I'll study all that in more detail. The first things first, though, like I said, safe power up, get a signal in it, keep it heavily current limited. I just want to see what's going on the functioning channel, like I said. And not to keep repeating myself, but Yeah, I do that though sometimes. But anyways, I want to, of course, gain access to the driver boards, amp boards, and the outputs, and start sussing out what may be going on there as to why those fuses opened up. So anyways, let me start that process, and enough admiration of the bottom side and all that. Let me get back around to the top side, start prepping up to power up, get a signal in it and all that. Alright, so I'm plugged into the current limiter, and in this video I'm not going to get into that. I cover that quite often, and I will again in the near future, but all I'm going to say about the current limiter for the customer's sake is up here, and let me get some garbage out of the way. So up here, if I kick the exposure down a little bit, there we go. You can see I have the device under test, the stereo receiver obviously, plugged into this box with the three light bulbs. There's three switches on the side, so I could bring in the different light bulbs individually or in combination, whatever. And it's the light bulbs, the filament of the light bulbs that act, of course, as a resistive element to limit the current according to what bulb I bring in or combination of bulbs. So I can heavily current limit this device under test, and then season to taste from there depending on the behavior of the unit. Obviously, when I start up a piece of equipment for the first time, I heavily current limit it, especially in this case where we know there's a problem. Okay, so, and then if a piece of equipment, device under test, behaves nicely and everything is good and all that stuff during the safe power up, then eventually I'll let it off the current limiter. If everything is okay, the bulb that I have pulled in initially that's going to give me the resistance I need to current limit and starve this unit of current, initially that should come up bright as the big filter capacitors in the power supply, the main filter caps, as they come up to charge. That's going to draw current, so there's going to be an initial brightening of that bulb, then it's going to dim down, and it should stay dimmed down. If it was to come up brightly and just stay there like that, then, that's not good. So, anyways, let me go ahead and start by powering it up. I'm going to pull in one of the bulbs. Okay, so let me step on in. And then when I power this up, you're going to see the bulb glow bright, and it should dim down, but if not, then something's trying to draw a heavy current. Like I said, the capacitors are initially going to draw that current, but then they should, everything should stabilize and that bulb should go dim. So I'm not going to get into a deeper explanation than that, but for the customer and for those of you interested, that's what we're doing, and that's what's going to be going on. So let's give it a shot here. I even heard the protection relay kick in. So that's good. And you saw the bulb just real quick. It increased in intensity, in luminance, and went down. Okay, so we know that. So, yeah, and that protection relay kicked in. So here's what I'm going to do now. I'm going to go ahead and shut it off. Okay. And let me do something around back, and I'll be right back. Okay, I'm back. So what I did is I swapped those fuses around to the other side, the good ones. And again, this is heavily current limited. So when I engage the power switch, if that bulb goes bright and stays on, then that's not a good thing. And if it does that, I'm going to turn it off immediately. But let's see what we have. Okay, so well, and our protection relay kicked in as well, and that bulb went down. But let me go ahead and turn it off anyways, because regardless, I want to know why the fuses went. Sometimes fuses just go, you know, it does happen. But I want to examine things, of course, a bit more. Let me reposition camera. So let me go ahead and prep up for that and move some things around, and I'll be right back. Okay, so I have the unit on its face, on padded blocks, of course, and I removed this cover here. It's just these 4 screws. I put these screws back in the heat sink so I don't misplace them, you know. So anyways, these are our amp boards. We have some nice beefy heat sinks here, so I want to pull these amp boards, you know, one way or the other. That's going to need to be done. So just because everything was looking good on the current limiter, when I swapped the fuses around from the good side to the bad side that had the open fuses, the blown fuses originally, that doesn't mean that there's not a problem going on. There could be an intermittent problem that's cropping up, causing the fuses to open up. So until I would, you know, start going into some more detailed and kind of serious bench testing, meaning, you know, driving this thing under load and, you know, keeping a tight leash on it, but just monitoring things to see if there's going to be some misbehavior going on, and, you know, some intermittent shorting or whatever the case. Until I do that, I don't know. Just again, it was a good sign initially that the you know, when I swapped the fuses around, that the bulb came up brightly and dimmed down quickly. The protection relay engaged, all that. That's good, but you know, that may not be the full story, or, you know, the full picture. That may only be a temporary thing. So again, why did the fuses open? Was it just something that happened because this thing was being pushed too hard, and, you know, whatever the case? And sometimes, you know, do the research for yourself as far as old fuses. You know, fuses can open up, especially really old fuses and all that. You know, things do happen. But I still need to do my due diligence if the customer wants me to press on. So I need to suss out as much as I can. So I think that if there is some kind of an intermittent problem, I'm going to probably bank on the fact that it's probably something in the amplifier section. Yeah, maybe there's something power supply related. You know, who knows what could be going on there. But, you know, that's a possibility between the power supply and the main amp. That's more than likely where the problem is, if there is a problem, even something intermittent that's just creeping in. So that's why I want to start there. And this is obviously a candidate for a restoration as far as recapping and all that stuff. It's a really nice unit. It should be done. I really don't have the time to do a full recap on it right at the moment, unless the customer can wait it out. But at the very least, like I always say, you know, the power supply should be gone through in detail, recapped, and everything, again, tolerance checked, and the amplifier section for sure. Those are areas that should be rebuilt right off the bat, you know, restored right off the bat. So I'm going to get this powered up again. I already swapped the fuses back over, and I do want to see that channel as I go through and play around with the controls, because I want to know, you know, again, even though I'm repeating myself, I want to know how good or how bad the controls are. I know this section lifts out, so if I can gain access to all the switches once this is removed, that's going to be a beautiful thing, and you know, it's going to make life easier. And the good thing about these switches, from what I can see, at least this one here, is that the rear of it is open, so I can flood those switches, work them and work them and work them. So if they're all like that, that's great. So anyways, that's that. So let me go ahead and start by getting this powered up again, get a signal into it, and we'll go from there. So I have a signal injected into the auxiliary in, a line level signal of course, from the function generator. You can see I have the scope probes on the speaker outs. And what I decided to do is reinstall some fuses into the bad channel. And the reason why, you recall, when I performed the safe power up, I decided to swap the fuses from the good channel to the bad channel with the open fuses, and when I did that, there wasn't any indication of any heavy current draw, anything trying to short out, and I demonstrated that. Again, I want to emphasize that that doesn't mean that there's not going to be a problem that crops up. That's why I still have this unit on the current limiter. I'm not going to let it off the current limiter. This receiver needs work, without a doubt. Just its age alone, I'm not going to go into all that again. But anyways, let me show you what I have over here on the scope. Okay, I'll go ahead and zoom in just a bit. Good enough. Well, I'll get closer. What the heck. So anyways, what you're looking at is both channels. So, I have fuses in all the channels. I've been monitoring things for a good few hours. Not a single hiccup other than some issues with the controls, as expected. Some of these controls are a bit intermittent, a bit noisy. I'm not going to go into a full demo on the controls. I will mess around with a few, but other than that, it's doing pretty good. Every once in a while, the volume control acts up. I've been messing around with the volume control as I've been monitoring things, and every now and then the volume control gets a little bit fickle when I run it through its range. I'm not going to take it all the way up right now because, again, I have the current limiter on and all that stuff. Oh, and I do have a load on the on the amp on this receiver because I want to run it with a load on it. And anyways, yeah, everything is holding up pretty good. I think I worked most of the kinks out of the volume, because when I first started messing around with this, when I first put a signal in it and started bringing up the volume was actually pretty nasty. A lot of static and some intermittent behavior, but right now it's actually doing pretty good. Sometimes if you just exercise the controls, even prior to cleaning them, they'll clear up a bit. Now that won't last, but just for testing purposes, sometimes if you exercise it enough. And then my selector switch, that's some AM stuff, and here's FM. I'm actually tuned onto a station, or I was. I don't know. I might have bumped it off the station, but that's okay. Anyways, I was getting some stations. I think the tuner aspect of this is just fine. But the point is that, see, there's noise. There's noise in these, yeah, look at that. There's noise in these switches, the selector and all that. When you switch modes and all that, you'll get some noise. Yeah. But anyways, the controls, though, actually are not that bad. That's good. They are going to need to be cleaned. I mean, I would definitely recommend that all the switches and pots are cleaned for sure. But yeah, anyways, and here's our balance. The balance is not bad at all. You see a little bit of noise there, you see that? But otherwise, all things considered, yeah, a little bit of noise, a little jumpiness, but let me switch over to a square wave. Okay. And let me work the tone controls there. So our treble. Okay, let me bring it back to center. All right, our bass. Okay. There's some, there's some noise in the base pot, more so. All right. And to heck with it, I'll go ahead and go through some of the switches, our low filter. And sometimes these switches will stick a bit, even when I disengage them. See, like I just disengaged it, and then let me just give it a tap. You see? There you go. Now we have our normal waveform again. But sometimes, yeah, see, when I disengage a switch, it kind of distorts the waveform a little bit. It kind of gets a bit sticky. Here's our high filter. Well, yeah, all these switches need to be worked. They need to be flushed out. And you can see some noise in the high filter switch there. Surprise, surprise. This loudness switch gets a bit fickle as well. It'll stick when it's disengaged. Here's our tape switches, and you can see the noise in it. Surprise, surprise. There's the other tape monitor switch as well. So anyways, switches and pots need to be serviced, but other than that, let me go ahead and switch views again. Oh, and one more thing too, just so you guys can get an audible representation of what we were looking at on the oscilloscope initially, and I switched back to a sine wave, by the way, but let's just go ahead and listen to both channels. I've got my signal tracer and my little amp, but you'll get an idea that there's no crazy distortion or crackle or anything funky going on. Here's the left channel, and this was a channel that had the open fuses, by the way. So let me if I can see that terminal, there it is. Okay, and of course here's our right channel. So yeah, they're both doing good. They're audibly, they're symmetrical, audibly or equal, whatever. There's no funky audible distortion, and of course, I'm just listening through this little mini amp, but it's very clear here on this end. There's no funkiness to it at all. I can tell, I've got good ears. I can tell that everything is doing pretty good. So I just wanted to demonstrate that too, because it's one thing looking at the waveform, and you saw that the waveforms were actually looking good. The waveforms were clean. They were symmetrical, but it's another thing, hearing both channels audibly as well. So let me go ahead and switch views. All right, so I transitioned back to a square wave, and that's what I'm going to do is sit here and monitor things for a while. I'm going to be working on some other stuff and, checking on this every so often, make sure everything's still looking stable. I want to work this thing, and I'm making it work right now. I've got some, I have some volume kicked up. I've got this square wave injected. It's hooked up to a load. It's working. So that's what I want to do. I want to be able to give the customer a little bit more information and let him decide as to what he wants to do based on his budget, how much future proofing he wants to invest in this, and also, last but not least, is my own schedule. Because I have a lot of restoration work that I'm currently engaged in, and more in the queue, a lot more in the queue, plus just the regular old repair work, I've got quite a full plate, and I don't want to keep piling it on and increasing my turnaround time more and more. As it is, I have a pretty lengthy turnaround time. I have a pretty lengthy waiting list. It's just the nature of things. But the moral of the story is, I think that at the very least, and as I always say, is that the customer should, if he's able to, have me service the controls, all the switches and pots, so that we can start there and hopefully remove any potential problems from, you know, popping in and out, because that's what happens with, you know, intermittent, dirty controls. You know, a lot of times you'll have issues with, you know, the signal kind of dropping out or becoming distorted, things getting crackly, noisy. So that will at least assure me, for the most part, that I've at least done that we have some clean controls, and hopefully that will remedy any problems with the controls for some time to come. And the next thing that I would recommend, based on the current behavior of this receiver slash amp, based on its current behavior, the fact that, like I said, we obviously don't have shorted outputs, the signal path on that channel that with the open fuses is obviously okay, because we have a good clean channel. As simple as that. Is it going to hold up? I don't know yet. But the point is, when I pull the boards, if I go that far and start working on the amp boards and all that, obviously I'll get a clearer picture. I'll be able to tell more up close and personal if there's been any work performed on you know, in the amp section. Like I said, what type of components are on board, factory components. So I don't know yet, we'll see. But at the very least, the power supply in the amp section should be restored. Components, tolerance checked, make sure everything's within spec, make sure all the voltages are sitting where they should. Look at the solder joints, make sure that everything's looking good there. Reflow solder joints as needed, and just do a really good thorough job in the power supply and in the amplifier. That would provide a pretty good degree of future proofing, because again, based on the behavior of this unit, it seems to be pretty rock solid. You know, as I've been sitting here, you know, jaw jacking on this topic, you know, you can see over there that, you know, that square wave has remained stable. And like I said, it's been over a few hours now, not a single hiccup other than a little bit of noise in the controls and a little bit of fickleness with those switches and so forth. But other than that, it's holding up. So there you go. I'm just going to leave it at that. I'm going to send the link to the customer. I'm also going to get in touch, because not all customers want to sit through a video like this. So there you go, guys. I'm going to leave it here, and I'm going to keep monitoring things. This will be part one. So if you're interested in this unit, this is a really nice unit, by the way. I really like the way this thing is built. It's a good rock solid receiver. And I know these things sound nice when they're operating within spec. So if you like this unit, and I get the green light, stay tuned for part two. But anyways, guys, as I always say, peace, love, music, and the vintage audio that brings it to your ears. Till next time, y'all take care.
This has been a Spinning Head production.